you want to say?
I have to tell people how to get their PDHs.
Ah, so some of these people are probably interested in what you have to say. Here, I'll loan you my microphone.
I'm loud. I just get to stand here.
Okay.
Congrats on getting stuff through the assembly.
Yeah, we were actually pretty shocked that it went that smoothly.
Yeah, it sounded like it didn't really have a hiccup too much. So.
No, we were kind of taking bets on what the outcome would be, and most everybody was either 7.4 or 8.3, and then of course Christopher Constant didn't show up, so that threw everybody off because it's now a 10 horse race instead.
Yeah.
And then to only have one person that we knew was going to vote against us. So
yeah.
And pretty much it didn't matter what we put up there. She was going to say no.
Yeah. No. There's always those. And it sounds like we'll get Mark back in to do the other part of this presentation later. I'm going to write up the draft for the senior design, and I'll send it your way.
Okay.
RFP. Would you be able to come to class for a half hour one of these
Sure.
Wednesdays? Okay.
The only thing on Wednesdays, what time?
2 to 3.
Oh, yeah.
Okay.
Wednesday mornings are ugly because there's usually always meetings in the mornings.
Okay.
So, yeah, no, I can do that.
Okay.
Anytime you want.
We're classifying you in your role as a experienced client.
Oh, okay.
Unlike we had it last year, we had the Greek Orthodox Church bring a project to the table, but they're like, yeah, we want to do all this stuff. We have like $10,000. Someone's like, you can probably get your permits for that much.
Somebody's already been there, huh?
Steroids?
Yes.
What are you talking about?
I don't know.
What am I talking about?
Yeah, are you talking about anything related to steroids?
No, I'm talking about leachate.
Is there steroids in your leachate?
Probably. Everything that gets thrown in there shows up somewhere.
Someone picks the password, usually based on something the speaker said. So, did you
Okay,
write that word
I'm on steroids, man.
I don't know if you're taking them right.
This is an exciting hazard. So, yeah, they swapped around presentations at the last minute.
Oh,
That was from the former, yeah.
Oh.
So what we could do, I don't know if it's big enough deal to do it, but what we could do is try to redo the password.
No, it's fine.
Oh, just call it steroids, you know.
And it's gonna be a random thing.
That's why they have drug take back though, you know.
Yes. Good tie, yeah. We can give it back.
Okay, I think we're gonna get started. Andy, we're good? Okay. So thank you all for coming to the seminar this week. We've had a little bit of a shuffle due to ongoing activities within Solid Waste Services. Mark Spafford was not able to do his normal talk today, so we got another Mark to do it. Mark Madden is going to give a talk still related to the Solid Waste Services. For those of you seeking professional development, there is a sign-in sheet floating around, as well as the password associated with the talk that is not being given is steroids. So forgive me for that. Mark, you have we have an hour until 12:45. And when you take questions, repeat the question because you're the only one with the mic and it's being live streamed on the internet.
Okay.
Thank you.
All right. Without further ado, I call this Water Everywhere because it's about landfill leachate, which is basically one of our greater challenges these days. And as I was telling people, it's a little bit early in the process because I was hoping to do this this presentation in the spring when we were more completely done with the study. So it's a little bit early in it, but then on the other hand, I got a whole room full of engineers that can help me today, right? So real quickly, to get you guys oriented, this is the Anchorage Regional Landfill. Everything inside this white road here will ultimately be filled with trash. That's the boundaries of the landfill itself. It's about 165 acres. Right now, everything that's inside that purple line there is liner. So there's 132 acres of liner. Just a few other fun facts. We take in about 300,000 tons of trash a year, 1,000 tons a day. We've been open for 30 years, so guess what? We got 9 million tons of trash out there, which is about 36 to 38% of the total volume of the landfill. So right now, our most recent estimates, we have about 37 years left of airspace in the landfill. So what's leachate? The Solid Waste Association in North America, in their Manager of Landfill Operations manual, defines leachate as liquid that forms when water travels through trash. And basically, most of it is driven by precipitation. There is some water that comes in with the trash. You get the dumpsters full of water when it's raining. There's also some liquid that gets generated as the trash decomposes. But for the most part, it's precipitation. And back in the good old days, like in about 40 years ago when I started doing engineering stuff, and the solid waste regulations were only 4 pages long. They're 178 now, by the way. We didn't have too much of a problem with leachate because basically it rained and worked its way through the trash and ultimately went off to the groundwater, out of sight, out of mind. We didn't worry about it. But unfortunately, that probably proved to be not a good idea. So about the 1980s, we started putting in liners in. By 1991 or 92, RCRA Subtitle D came along and mandated that you had to put in liners. So then all of that good stuff that was just kind of going away started accumulating on the liners, and then you have to pull it out and treat and dispose of it. So what we do at the Anchorage Regional Landfill is we collect it all by gravity, and this is a picture of what it looks like as it's coming out of the landfill. This nice crystal clear, good looking stuff. A little foamy, but you know, it's looking pretty good. So we take that and we run it through this pond here. It's about a 1.2 million gallon pond. We have, of course, bubble aeration in the bottom of it. It hangs out there for anywhere from 3 to 7 days, depending on how fast it's coming in and how fast we can take it out. And after it's gone through that, we load it on these trucks here. They're 6,000 gallon tankers. We drive it from the landfill to the septic hauler's drop-off station at Turpin Street and the Glen Highway, about 7 miles away. So what's in it? So this is a picture of what it looks like as it's going into the truck. Not quite as crystal clear as what we had coming out of the bottom, but these are the most common parameters that we test for coming out of it. The red ones are the ones that AWWU gets the most excited about. Out of all of those, zinc is the only compound on that list that we actually have a numeric limit for, and they're changing it on us. It has been 12 for quite a few years, 12 milligrams per liter, which was a local number. The EPA is they're changing it to the EPA's recommended number of 5.6. So as you can see, we're starting to get pretty close to it here, and actually about 10 to 20% of the time we won't make that limit if we don't do something else with what we do. The other thing that AWWU gets really excited about is the BOD here, because it is totally soluble. So basically nothing that happens after we discharge it reduces that BOD. I mean, there's nothing at the Asplin wastewater treatment plant that will reduce that BOD. So that just keeps going right on out and adds to their limits, or to their discharge quantities. And then suspended solids is obviously a concern to AWWU, because those suspended solids don't necessarily always stay suspended, and they start to build up in the sewer lines. And also they have limits of how much they can discharge through Asplin. And so, like I say, the zinc is a numeric number. The suspended solids and BOD numbers are more of a mass loading, depending on basically how many pounds we put out per day or per year, which is a concentration times the volume we put out. So the one thing, there is lots of other things in there, lots of trace compounds, because obviously that water comes in contact with everything that you folks throw away. And so there's a lot of like a grocery list of things in the parts per billion, parts per trillion, but it is not considered a hazardous waste. So this graph here, the blue bars show exactly how much leachate we produce every year since we started hauling in 1991. The red line is the amount of precipitation that falls on the landfill in the lined area, and we normalized it to acre feet. So you can kind of see that it has a pretty decent correlation. You know, how much water comes in, obviously, is how much goes out. These little red dots that you see along the bottom are different. Every time there's a red dot is a year that we actually expanded the liner. So in 2014, we added 26 acres of liner. So guess what? We have a pretty good spike up here. It probably would have been a lot more evident, except for 2013 was one of the wettest years we had on record. And 2012, we had 186 inches of snow to deal with. So that kind of masked out these two bars here were kind of more influenced by precipitation than area. But at the end of the day, in 2017, we hauled 29 million gallons of leachate, a lot of water. And especially when you're doing it at 5,000 to 6,000 gallons per load. So this shows how much we deal with as far as truckloads. And if you look down here, when we first started, we were producing about 3 million gallons, maybe, 10, 12 trucks a week. One guy'd take a truckload every day. Life's good. Get over here to 2017, we had 5,200, almost 5,300 truckloads, over 100 truckloads a week, which works out, depending on whether we're hauling 6 or 7 loads a day, or 6 or 7 days a week, somewhere between 14 and 20 loads a day. So we have 3 trucks and that are running pretty much constantly every day we haul. We can't do more than 3 because the traffic capacity at the drop-off station at the septic hauler station at Turpin Street and the traffic capacity at our loading station pretty much limits it to, if you get more than 3, you just got guys sitting around waiting. So if we have to go to if we have to add more capacity by truck, we're pretty much going to have to go to 2 shifts, be hauling 24 hours a day. So we started thinking about this, going, we gotta do something. And so the first and most obvious answer is the easiest answer, right? Being good engineers, let's look at the easiest way to go. So this line right here is the actual existing sewer system on J-Bear. The blue is actually Elmendorf sewer, and then the green is Fort Rich. And this little red line is about 1.5 miles. So this is a no-brainer, right? We put a lift station right here, either a force main or a combination force main gravity sewer, and we're hooked up. Except for one minor detail. The green line on Fort Rich is now owned by Doyon Utilities, a regulated utility under the state of Alaska. The blue line is owned by the Air Force and managed by the Air Force. And then there's AWWU over here, another regulated utility. Just to make all this real happy, this area right down here is AWWU service area. This area way up here is AWW service area. This orange box is AWW service area. But everything else around it is Doyon Utility service area. And so the landfill is actually like an island sitting out there. We can't get anything out of there utility-wise without going through Doyon Utilities. So you add to that, then you get to deal with J-Bear for any kind of permitting, any kind of real estate, any kind of environmental stuff. And I don't know if you've ever dealt with the J-Bear in the military. The military does one thing quickly, and it isn't paperwork. And then once you get through all of the folks at J-Bear, you get to deal with the Air Force Center for Engineering Excellence and the Pentagon to finally get anything signed off. So every time we go to a meeting on this thing, we have like 25 to 30 people in the room, and everybody knows that the productivity of meeting is directly inversely proportional to the number of people in the room. So if you got 25 people, you get nothing done. So when we put this together, if SWS were to build that whole red project, it'd probably be about $5 million. Now, because this piece down here is actually on in Doyon Utility Service Area, we're kind of kicking around whether they should build it and operate it, or should we? In which case, our cost would go down to build it, but more than likely they're going to get it back from us. I mean, that's a given. So, but as I say, it's about $5 million. When we first started looking at this, right now it costs us about 4.5 cents a gallon to get rid of that 29 million gallons of leachate, by the way. It kind of came out to, I think, about 2 cents a gallon, around there, 2 to 2.5 cents a gallon. But when you started looking at all the things that came up, you know, Doyon's going to pile on their fees for putting it through their system, and you know, their O&M costs for their line. The folks down at Elmendorf, they can kind of get their take on it too. And then we're still not sure exactly what AWW would charge us at the end. And we don't even know who we would end up paying, because would we be paying Doyon to discharge there, or would we do a mathematical addition subtraction and just figure out what we put through to AWW at the other end? It's a lot of questions that are still waiting out there. The other entertaining thing is there's all kinds of different discharge requirements. In Doyon's certificate with the RCA, their discharge limits are significantly less than what we have to discharge to AWW directly. So if we have to meet that, then all of a sudden we have to add a whole bunch more pre-treatment. And we don't even know what Elmendorf is going to want to put on theirs, or how that's going to work with their discharge permit. So at the end of the day, it's a real short piece of pipeline, but it's kind of like that picture there. Okay, so you're kind of looking at a giant canyon between here and actually making it happen. So the next thing we went to is, well, let's skip J-Bear and just go straight down the highway. There's lots of other utilities that go down there. Good or bad news, we have to deal with the DOT, obviously, to get right-of-way permits. But one thing most people don't know is that the DOT doesn't own the land underneath the highway. It's still owned by the military. So ultimately, guess what? We get to deal with J-Bear again. But again, like I say, all of a sudden, there's a lot less players on the picture. When we put that one together, probably about $12 million. When you start putting in the cost of maintaining that pipeline and the lift station, probably about 3 cents a gallon. So it's definitely a savings. It's definitely a little bit easier route to deal with. But, you know, again, like I say, working out the right of way and which side of the highway you put it on, and there's lots of utility conflicts out there. So anyway, while we decided to look at something besides pipeline, and so this is a leachate evaporation system. There's a bunch of different technologies out there, but this is the one that we kind of found seems to be the most reasonable. This is by a company called Heartland Technologies. This big gray stack right here is actually just an enclosed landfill gas flare. We have one at the landfill right now that we use to burn off all the gas that we don't sell to Doyon Utilities. At the other end is a great big blower right here. And what happens is this blower pulls all the hot gas that's generated as the landfill gas burns in the flare through this pipe across here. This is a little mix valve so that they can bring in some fresh air to lower the temperature, because it comes off here about 1600 degrees. And they want it about 1200 when it gets to this brown section right here, which is where the hot air comes in contact with the liquid. And then what happens is the temperature drops significantly, and you produce this saturated stream of air that goes out the stack here, very much like you see at the MLMP power plant out there at Muldoon Road. and where you'll end up with just a great big steam plume of white steam coming off of here. Everything that doesn't get evaporated gets pulled out here in this box right here. So they can pull off about, we can evaporate off about 90% of the liquid, and you end up with two things. One, as I say, the saturated air that's going out the stack, and then this other liquid that's got everything that won't evaporate in it. So it's a pretty heavy liquid. But what most landfills that do this do is they'll take that back and recirculate it back into the landfill. So when we started looking at this project, right now we produce about 2,500 CFM of landfill gas at the landfill. Right now, Doyon Utilities takes about 60 to 80%, depending on what they're doing. But we end up flaring off about 800 CFM a day on any given day. So we started looking at this, and they have the 50,000 gallon per day units that run at about 800 CFM. So it's a nice fit for us. So we kind of penciled this whole alternative out using just 2 of those evaporators, because we're pretty sure we can get 1,600 CFM going forward, either between the way that Doyon operates or the fact that we know we can pull more landfill gas out of the landfill. You know, the overall cost of the units themselves cost about $4 million by the time you hook up all of the piping to get the gas and the leachate and all the other utilities and what have you. It's probably about a $7 million project. What we really like about it is we don't have the meetings with 25 people. We pretty much control our own destiny. We don't have to worry about what somebody's going to let us do down the road. All we have to do is meet our air permit that comes off of that. But with every silver cloud, there's a gray liner. So anytime you put something in the air, you have the potential for odors. We already have enough issues with odors anyway, but to me, when I smell leachate, I smell a nice earthy, fairly pleasant smell. But again, I'm also the guy that thinks that landfill gas smells like money. And so some of you guys might take me up on that one. The other thing is this, where we would be putting this is within 2 miles of Bryant Field. So we put this big plume of white steam up into the air. We're not 100% sure how that's going to fit in with the airspace requirements for Bryant Field over on J-Bear. The last kind of drawback to this is right now we haul about 120,000 gallons a day. And ultimately, when we get that last 32 acres lined, it'll probably go up to about 140,000 gallons a day. So at the end of the day, even if we built all this, we would still have to keep some trucks on the road. But if you're hauling 40,000 gallons instead of 120,000 gallons, that's eight trucks versus 22. So it does have it is a fairly attractive alternative to us. So the next thing we looked at was deep well injection. They do this a lot in the oil field, and there's actually about a half a dozen of them here in the Cook Inlet Basin. They do it quite a bit up on the North Slope. The challenge to it is that you have to get it deep enough to a point where you're the water of 1,000 parts per million in total dissolved solids. And so, you know, anywhere you go, usually there's a fairly freshwater layer that's shallow, and then you have to get down to a point where not only is it that high of a concentration, but it's also hydraulically separated from the fresh water. So obviously this alternative takes a little bit of pretty high pressure to make it happen. When we did a real quick tabletop study, this McHugh-Oyak formation is basically this blue stuff that you see as the tops of the mountains. And then that dips down underneath all these quaternary deposits that are pretty much most of Anchorage and everything out toward Kinnick Arm. but to get down to that level, we estimated we'd need wells that are about 6,000 feet deep. To be able to get rid of 140,000 gallons per day, we needed about 5 wells spaced at 1,000 foot on center. And the 1,000 PSI is what the operating pressure of most of the injection wells in the Cook Inland Basin that are operating right now operate at. That's probably a minimum number. It might be a little bit higher because this is deeper than than some of the wells that are out in Cook Inlet. So most of those are about 4,000 to 4,500 feet. So that's all good until you hit that number there and you start to inhale a little bit, because it's a pretty expensive proposition. When you start thinking about drilling 6,000 foot deep wells, you're into a couple $1 million for each well. So we don't have the actual operating costs together on that one yet. But when you start thinking about operating a whole injection system where you've got equipment that's running at plus 1,000 PSI, it's going to be expensive. I just know that from operating things at 10 PSI. So one other question that comes up a lot is, well, why don't you just go to the Eagle River treatment plant? It's 2 miles away. And it seems like it'd probably be a good idea. It'd be a pretty easy alternative. The biggest challenge is getting across the river. But a couple things. The Asplin treatment plant out at Point Warrenzoff is a primary treatment plant. Basically, they remove everything by mechanical means, and they're pretty minimal at that. When you get to Eagle River, it's a tertiary treatment plant. So they have mechanical and biological treatment, and probably some more if there's an AWW person that could tell me more about that one. But it's quite a more involved process. Asplin discharges to Cook Inlet directly. So there's a lot of dilution. I know dilution is not the solution, but there's a lot of dilution that happens when it gets into the inlet, whereas the Eagle River treatment plant discharges directly into Eagle River. So obviously they have a lot higher standards for their discharge as well. The other thing to think about is that Asplin is a 60 million gallon a day treatment plant. Eagle River is 2.5 million. So when you start throwing 140,000 gallons into these treatment plants, 140 into 60 million is pretty minimal, but you start throwing 140 into 2.5 million, and all of a sudden it becomes a fairly significant number. So we've kicked it around. There's not a lot of interest on the AWWU side, and our thinking is that to get there, we would almost be producing drinking water to discharge it. So it's probably, from a feasibility standpoint, not likely, and from a cost standpoint, even worse. So some other stuff to think about that we have to worry about. This is our entire leachate treatment area. This is the actual pond that we use. This pond is right now used as an overflow pond. We'll probably put it in use for a polishing pond possibly next year. But all of those facilities are at least 20 years old. So those liners have been sitting out in the sun for 20 years. All of these aeration pumps have been spinning along for 20 years. I don't know how many thousands of hours are on each of them. They still run like a top, but at the end of the day, we pretty much need to do a lot of replacement. And depending on how carried away we get, it's somewhere between 2 and 4 million just to replace what we have. Then, oops, wrong button. Then on top of that, as I said, AWWU is already for our next permit, which goes into effect September 2019, is lowering our standard for zinc. And down the road, they could actually start imposing limits on our BOD and our TSS discharges. So when you start throwing in all of that sort of stuff, we've done some studies on how we might be able to achieve the most stringent requirements that AWW has thrown out on the table as maybe, and we start getting into $20 million just to treat the water before we discharge it. So, so as I say, there's lots of moving parts in this whole process. Me being the engineer, I'm kind of still, I'm about, my favorite horse is still the evaporator. If I had to take a second, I think the highway route pipeline might be the second choice. But again, is a lot of interaction that's going to have to take place, but not nearly as much as trying to deal with all of the people going through JBER. So with that, I'll open it up to any questions, discussion, or what have you.
So Mark, can you expand a little bit on how you guys collect methane, how it's used for power that evaporation system?
Okay, so yeah, so I'll go backwards here a little bit. So the question is, how do we collect methane, and how do we use it? So this is the original landfill area. Right now, in the older portion of the landfill, this northern half, we have about 60 different wells and horizontal collectors, and we pull that all through. There's a little building right about here, and it's got a couple blowers in it, and we pull all of that gas through there. Right now, there's another building right next to that where we do some processing, mostly to remove the water. And when you remove the water, you remove some of the other things that they don't want to run through the generators. And then it's put in a pipeline and goes down here to this little red building down here in the lower, I guess the lower left corner, which is the power plant. And it's got 5 internal combustion engines and will produce 7 megawatts of power. Running full speed. Right now, there's room for a 6th. At full capacity, that's 2,500 CFM max. What we, as I say, anything that we don't send to there is burned in a flare that sits about right here, and it's very similar to that gray tower that I was showing you earlier. And basically, it's just heat going up a big stack. If we were to go to an evaporator process, probably we would end up putting that facility somewhere in this area. It'd be very easy to tap into it because there's a great big header that connects all of the gas lines that loops right around here. So it'd be fairly easy to pull a tap off of there, put its own blowers over there. And that would be fairly close to the leachate ponds here. So we'd obviously have to have a lift station to pump that up to the plant. But like I say, that's in that $3 million above and beyond. Does that answer your question? Okay.
But I guess the point is that the methane is used to power the evaporation system. Right?
Yes.
That's the major source of energy.
Yeah, the methane would be the main source of energy for the evaporators. Now we can set them up to run on natural gas, but that's a pretty steep price because when you start talking about the amount of natural gas we're using. Oh, well, I kind of repeated the question in the answer, but but yes, but anyway, and now I lost my train of thought. It just left the station. So yes, the landfill gas is the primary energy, and as I say, we could put it could set it up so that we could burn commercial natural gas, but it would be fairly expensive to do that. Any other questions? Yes, sir. Go ahead.
You have concerns about the air quality here. You'd be discharging there. You might have some metal dust in there and other things.
The question is concerns about air quality with the evaporator, I assume. Primarily, everything that comes out the evaporator is pretty much just it's a fairly low temperature, about 100 degrees. Highly saturated, mostly with water. Everything else falls out, and so things like metals and all that would be included in the sludge that gets pulled out in the box. If I can go down to that slide a minute. Ooh. So everything else gets pulled out in this box right here. and it's still in a wet situation. So it really stays wet, so they doesn't produce a lot of dust. Obviously, that would require an air permit, and we would have to address that. Would probably be just an addition to our existing Title V permit.
Your sludge is probably still only like a couple percent solids, correct?
Yes. Yeah. Yeah, you're probably maybe like 3 to 4% solids by the time it comes through there.
So my other question is on you say you're collecting methane from the northern side of the landfill. Do you guys still do much active placement in the northern side of the landfill currently, or are you working in other cells?
Currently, we're working in other cells. I should have put these two slides closer together. Currently, we're working. The question is, are we still putting trash in that cell? Currently, we're working in this cell right here, which is what we call cell 1112. It's kind of about midway down on the right-hand side of the landfill. If you're on and you can't see, if you're online and can't see the dot, but the way the landfill is built is that ultimately this landfill will be from bottom to top about 300 feet. What we do is we dig down about 100 feet to start with. And so this area right here is probably at the bottom level. And so then we fill that area back up. The problem is you can't just go from 0 to 300 in a small area from either a static stability, or you start adding our earthquakes and all of a sudden it's just not going to work out. So what we have to do is way up. So we filled this area, and then we built this area, and then we'll fill this area, and we'll fill that area, and it'll slowly work their way up. But this area up here still has about 75 more feet of trash to go from where it is right now. So yes, we're not putting any trash in there right now, but that's future. There will be more trash going out there. So I think this gentleman in the back had a question.
Yeah, I had a question on the sludge evaporator.
Uh-huh.
Is there a risk that would be a hazardous waste?
No. The question is whether the sludge from the evaporator would be a hazardous waste. Well, first of all, it's not really a sludge. It's more of a slurry. And as I say, basically it just concentrates everything that's in the leachate to start with, which isn't a hazardous waste. And generally the way EPA and it's been looked at other landfills, if you're just putting it back into the landfill, that's acceptable. As a matter of fact, that's what we do when we clean our existing ponds. We'll pull all of the solids out of there, dig a hole up in the landfill, and take it back up there. So it's not considered a hazardous waste, and we can manage it on site. Somebody else had a question, I thought. Okay, maybe not. All right. Yes, sir.
I'll keep pestering you for early. So, has there ever been any studies to assess how to reduce the amount of leachate produced before you even have?
The question is whether we've looked at reducing the amount of leachate rather to get rid of it before it's ever generated, correct? Umbrella, yes. We have thought about it a lot. We haven't actually paid a consultant to do any studies on it because it's kind of a no-brainer that, yeah, if you can limit it, you can definitely reduce the amount at the other end. As I say, one of our biggest problems is that most of the landfill, there's absolutely nothing on this landfill that's closed officially. So every square foot of that landfill will at some time in the future take more trash. One of the things that you can do is put like a membrane or put some sort of impervious layer or something just to make the surface shed more of the water. But before you put anything more on that, you then have to go in and thoroughly destroy that, because if you don't, what will happen is the leachate, the water will fall on the surface, work its way down till it gets to that impervious layer, and then start gushing out the side. And that's in landfill business, that's a real bad situation because usually it isn't pretty. It's usually this bright orange stuff that's kind of oozing out the side. And people get all excited about, oh my gosh, there's hazardous stuff coming out of there. It's not hazardous, but it's a perception thing. So yes, we've thought about it. There's, one of the things that we're definitely trying to do right now is just get more vegetation growing. Because if we can get the vegetation in the root system, will help kind of reduce the permeability, and also the vegetation will use up some of that water. But in general, yeah, we're working on grading. We've considered some membrane systems. One of the other things that we're considering, if you look real close, this white box right here and this big gray surface right here, when we build the liner, we put in a geosynthetic clay layer and then an HDPE liner, and then we put 2 feet of crushed rock. And that white material that you see in these 2 areas is just that white rock exposed. And so one of the big challenges is that every time it rains, every drop of water that falls out of the sky is instantly in our leachate collection system that falls on these 2 areas. So going forward, some of the things that we're considering are possibly one, making some smaller our future construction smaller so we don't have so much exposed. But the other is to possibly put a membrane over that we can slowly work out of the way as we're going up. And so that's definitely a challenge. And as I say, that's just a direct shot. Every drop of water that lands there goes straight into our system.
Mark, can you explain a little bit about the months that you see your leachate flows?
Okay, the question is months for peak leachate flows. Usually there's 2 periods of the year that are extremely high. The first one is usually around May. Obviously, all of the snow that falls on the landfill is melting and showing up in about May. One of the things we do in the wintertime is we do try and shove a lot of the snow off of the surface into our stormwater ponds, so that we don't have to, so that we can get it off of the surface as much as possible. But everything that melts in April and May shows up in May and June. The other time of the year is right about now, because historically it rains pretty heavily in August and September. As a matter of fact, I think in that spike that I showed you of 2013, it rained every day in August and September. So those are the 2 peak times. And in those times, we definitely have trucks going 7 days a week. Right now, we're kind of actually tailing off. So we're down to about 6 days a week, and actually not even hauling full time. One of the guys not even full time on 1 or 2 of the days. So, but it is pretty variable. So, and that's why we have the overflow pond. Anybody else? All right. Well, I appreciate your help, and nobody said, well, why don't you do this? Other than you, Aaron, your suggestion I need to stop it before it starts. But
Hey, big umbrella.
all right. Well, thank you very much.
Okay, thank you, Mark. Again, the misaligned password is steroids or steroids. Steroids? One of the 2. Give them both a shot. Thank you.
When I started, what's that? Well, as I say, we're in the middle of a study right now.